New on Curiosity Stream. How do you connect a 16th century potato to limitless energy production? Could Napoleon's toothpick have a direct link to a machine that predicts the future? And how can a 1700s conch shell chart a course to humans connecting their brains to the internet? James Burke's visionary series Connections returns for a new generation. Experience all new Connections. With monthly, annual, and bundled plans, find the one that works for you at curiositystream.com.
Welcome to the Agrihood. Carnes Crossroads is a new home community with a farm-to-table lifestyle. Just outside of Charleston, here, community is defined by gathering together and our deep connection to nature. Our future farm and amenities are taking root and blooming into something you've always dreamed of in a fun, healthy, and social environment. Come home to the Agrihood, where you can plant roots and thrive.
Learn more at carnescrossroads.com.
This is SpaceTime, Series 23, Episode 107, for broadcast on the 12th of October 2020. Coming up on SpaceTime, lakes of liquid water found on Mars, how Einstein's description of gravity just got even harder to beat, and NASA's Northern Territory rocket launch program delayed by COVID-19. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have found evidence of a patchwork of salty liquid water lakes below the surface of the red planet Mars. These latest discoveries follows the detection of a large salty liquid water lake beneath the Martian southern polar ice cap back in 2018. The new findings, reported in the journal Nature Astronomy, suggest there must be multiple ponds of hypersaline liquid water below the surface of the red planet Mars. Like the previous results, the new findings are based on radar data from the Masters instrument aboard the European Space Agency's Mars Express orbiter. To make their discoveries, the authors borrowed a methodology commonly used for radar sounder investigations in subglacial lakes in Antarctica, Canada and Greenland, adapting the method to analyse both old and new Masters data. The readings show multiple areas of high-intensity reflections that suggest the existence of numerous extended pools of liquid water. Back in 2018, scientists using data from Mars Express detected an area of strong reflectivity in layered deposits of ice and dust about 1.5 kilometres below the surface near the Martian South Pole ice cap. The data suggested a liquid water lake about 20 kilometres across, lying on the original surface of the planet, which has since been covered over by layers of ice and dust. And unlike previous findings of water on Mars which were either frozen or highly seasonal, this reservoir appears to be permanently liquid. And because microbes can survive in similar environments on Earth, the Martian subsurface lake could also potentially host life, despite the extreme cold and salinity. The discovery sparked renewed efforts to better understand the sorts of conditions which would allow liquid water to persist in such an inhospitable area. See, although the Martian surface is far too cold and has far too little atmospheric pressure for pure liquid water to survive, the red planet is rich in chlorides, chlorates, sulfates, perchlorates, calcium, magnesium and sodium salts, all of which would significantly lower the freezing point of water, keeping it liquid down to temperatures as low as minus 74 degrees Celsius. The triple point of a substance is the temperature and pressure at which it can coexist in all three main phases, that is, solid, liquid and gas. For water, the triple point is found at 0.01 degrees Celsius and at 6.12 millibar, or 0.6% of atmospheric pressure on Earth's surface. Although there are some equatorial regions on Mars which do have conditions just below the triple point of water, most of the planet endures temperatures far below that. And when the atmospheric pressure is lower than the liquid's vapour pressure, the liquid evaporates through a process called sublimation. Pure water readily sublimates under the thin Martian atmosphere, which is just 1% of atmospheric pressure on Earth. However, salt solutions or brines don't evaporate or freeze as easily, and therefore would be more likely to remain liquid on Mars. The experiments suggest that water mixed with magnesium chlorate would be less likely to evaporate or freeze on Mars compared to water mixed with sodium or potassium chlorate. NASA's Phoenix lander touched down near the Martian North Pole back in 2008. It's the furthest north any mission has ever gone. And when mission managers photographed the lander struts, they saw droplets of liquid coalescing on the structure. Now, scientists believe these were droplets of saline water that had splashed up during the landing, and they remained in a liquid form for some time. As to where the water came from, well, a trench dug by Phoenix uncovered frozen water just a centimetre below the surface. So, Phoenix was landing, its rockets were firing, and the heat of those rockets melted some of the water, which then splashed up onto the landing structure. The new study not only confirmed the position, extent and strength of the original 2018 South Pole detection, but it also discovered 3 new separate bright areas, 3 additional lakes, each about 10 kilometres wide. As for this new study, it not only confirmed the position, extent and strength of the original 2018 South Pole lake detection, but it also discovered 3 separate new bright areas, that is 3 additional lakes, each around 10 kilometres across. In other words, the main lake is surrounded by several smaller bodies of liquid water. Now, at this stage, the authors can't determine if these lakes are interconnected or if they're each isolated bodies. One of the study's authors, Genzel from the University of Southern Queensland, says laboratory experiments studying the stability of hypersaline aqueous solutions have helped explain the presence of the liquid water. These experiments show that high salinity brines can persist for geologically significant periods of time, even at temperatures as low as minus 125 degrees Celsius, which are typically found in the Martian polar regions. Now, while the existence of a single subglacial lake could be attributed to an unusual condition, such as a volcano under the ice sheet, the discovery of an entire system of lakes implies that they're actually fairly common, and that suggests some kind of natural formation process that's probably been going on through much of Martian history. Now, taking that a step further, it could also imply that these lakes could retain traces of any life forms that may have evolved on the red planet when Mars was a warmer, wetter world with a denser atmosphere, something more similar to the Earth rather than the freeze-dried desert the red planet has become today. Caparelli says the findings confirm that the thick Martian ice sheets, far from being uniformly structured wastelands, should be viewed as stratigraphically and physically complex geological formations, deserving to be fully explored in detail.
Well, the new data have shown us that there are 3 other little lakes around the main one. They are all separated from each other by strips of dry terrain, and the smaller ones are about 10 kilometers across each.
It shows that the Martian environment isn't doing these things randomly, doesn't it? Because if it was just one liquid water lake, that could be a volcano or something that caused that. But to have, have more, that raises questions about, this is some natural geological process which occurs on Mars.
Well, that's right. You've been doing your research, actually. There was a paper published last year by a group in the U.S. that speculated that there might be volcanoes under the ice, or there could be an area of anomalous geothermal activity. For example, if there were magma chambers underneath the area where we found the first lake. But that would require really high geothermal gradients, and there is no evidence for that. Having found 3 more little lakes in the region, clearly, as you mentioned, it signifies that we are not looking at a unique occurrence, but we are looking at something which has much more global implications and very well linked to the climate and hydrology of Mars. In
order to allow water to remain liquid at such cold temperatures, it needs an added touch of something, doesn't it?
Well, that's right. Yes, we need some antifreezer. So pure water, obviously, at these temperatures will not exist in liquid state. In fact, we have ice there. But if we add some antifreezers, such as, for example, chemicals like salt, we know that salts depress the melting point of ice. And so you can have liquid even at temperatures which are very, very low, below zero. And in our case, we think that these antifreezers are probably salts generated by the absorption of atmospheric water onto perchlorates. And we know that there are lots of perchlorate salts on Mars. They have been found, they have been observed all over Mars. And so that may be a mechanism where you can generate very highly saline water that remains liquid at this condition.
And that wouldn't just need to be in the subsurface. That would be on the surface as well, on the shadowed side of craters.
We have found ice on the shadowed side of craters on Mars. So wherever, you have temperatures that are below the noon temperatures of Mars, so where the sun doesn't reach, the sunlight doesn't necessarily reach regularly, then we have found pockets of ice. Now, this would seem to be pure ice. Whether there is liquid underneath, it's a possibility. We, at the moment, don't have the tools to see it, but we hope that with future observations and with different techniques, we might possibly be able to observe liquid water also under the North Polar Cap.
When do you hope to undertake an observing campaign using Mars Express there?
Oh, yeah, no, we actually, our team is the team that runs basically mission control for MARSIS, for the ground penetrating radar. So essentially the request to the European Space Agency to fly the orbiter in certain locations depends on mission control in Rome, and we must request, of course, there are technical issues that have to be considered all the time, but basically we run the orbiter and therefore collect data wherever we need. It just takes time.
These three newly found lakes, are they at the same level as the 2018 discovery?
Yes, we assume that's because our measurement of the depth of the basement there depends on the type of geophysical parameters we consider for the ice cap on top. So we assume that they are at the same depth, around 1.5 kilometers below the surface. They could be a little bit shallower.
That would make you think that they're possibly in the same layer of strata.
Yes, we are thinking along the lines of them being basal, in other words, at the bottom of the ice cap, so on the ground underneath.
No evidence of any interconnectivity?
No, our data do not allow us that kind of resolution. What we can see, though, is that among the little bodies of water, there are dry strips of material because the geophysical parameters are such to be reconciled only with material which is relatively dry. So that might indicate that there is no connectivity among the various bodies of water, but we cannot say for certainty whether there is or not, because if there were connecting channels, for example, they would be too small to be resolved with our instrument. We just wouldn't be able to see them. Our footprint is extremely large, so the footprint of what we can see on the surface. So our resolution of features is not very, very good. We are talking, tens of kilometer size resolution.
I guess the other interesting aspect of this research is the hope that because life can exist under really briny conditions here on Earth, there's always the possibility that if life had existed on Mars, it might survive in these briny, watery pockets.
Yes, we obviously in our team, none of us is an exobiologist or a biologist in general. So we are all physical scientists of some sort and engineers. And so that's really not our area of expertise. But naturally, as you mentioned, there are extremophiles living on Earth. They have evolved in a variety of different conditions, including in very high temperatures, very low temperatures, very acidic environments, very hypersaline solutions. And so there is no reason to think that the same evolutionary processes might not happen elsewhere. So the presence of brines, even at those very harsh conditions, certainly opens up new avenues of research for exobiologists.
You must be taking a different view now when you see scientific papers looking at Lake Vostok and places like that in Antarctica.
Yeah, we are actually very interested in that kind of research. We are trying to run ourselves Earth analogs for our research as well. We have received requests of collaboration as well from science groups that are working on Earth in similar environments. So we hope to be able to establish also some collaborations to look at analogs on Earth.
How do you study an environment on another world without contaminating it?
Yes, and that's the beauty, if you want, of geophysical techniques, because like the radar, for example, we do not actually have to touch anything. Of course, it comes a point where you can do so much with modeling of the data from remote sensing guessing, and you need to get some ground truthing in order to refine the model. But obviously that's very, very difficult and needs to be done, especially if you're studying another planet, and needs to be done in full compliance with policies and regulations and science of exobiology in the sense of not contaminating potential sites.
That's Grazilia Caparelli from the University of Southern Queensland. And this is Space Time. I'm Stuart Gary. Still to come, they say don't bet against Albert Einstein, and it looks like that's been proven again with a new study on supermassive black holes, proving that Einstein's description of gravity just got a lot harder to beat. And coming up a little later, have you ever wondered what happened to that NASA Northern Territory launch program we talked about last year? Well, it's still happening, but it's been delayed by 12 months because of COVID-19. We'll have all the details. All that and more still to come on Space Time.
New on Curiosity Stream. How do you connect a 16th century potato to limitless energy production? Could Napoleon's toothpick have a direct link to a machine that predicts the future? And how can a 1700s conch shell chart a course to humans connecting their brains to the internet? James Burke's visionary series Connections returns for a new generation. Experience all new Connections. With monthly, annual, and bundled plans, find the one that works for you at curiositystream.com.
Okay, let's take a break from our show for a word from our sponsor, Namecheap.com. As their slogan says, search and buy domains from Namecheap at the lowest prices. Now, this is the service that our team at Bytes.com use to buy and manage our domain names, and we're really happy with the service, support and value we're getting. Buying the right domain name shouldn't be hard, and with Namecheap, we've found it to be anything but that. And you can find your dream domain and join over 2 million happy customers when you register with Namecheap. Trusted with well over 10 million domains, you'll know you're in safe hands when it comes to turning your website idea into reality. And they've got some excellent tools to help you find the right name, like the handy search engine. All you do is type in your desired name, cross your fingers, and press search. And if what you want's already gone, and it does happen sometimes, they'll come up with some great alternative ideas. And if you're looking for some new inspiration, try the new website domain name finder, Beast Mode. It'll help you discover thousands of domain names fast. We've found their prices to be excellent, management tools intuitive, and they're easy to use with excellent custom support if you need it. All in all, it's a great experience all round if you're looking to pick up a domain name or two. So why not check them out and help support our show at the same time? Just visit spacetimewithstuartgary.com/Namecheap. That's spacetimewithstuartgary.com/Namecheap, and Namecheap is one word. You'll find the URL details in the show notes and on our website. Just visit the support page. That's spacetimewithstuartgary.com/Namecheap. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
Well, they say don't bet against Einstein. And that's been proven yet again with a new study of supermassive black holes. Albert Einstein's 1915 general theory of relativity, the idea that gravity isn't a force, but rather the effect of matter warping the fabric of space-time, has withstood over 100 years of scrutiny and testing. And the newest test, by University of Arizona astrophysicists from the Event Horizon Telescope collaboration, just made general relativity and the good Professor Einstein 500 times harder to beat. Despite its successes, Einstein's robust theory remains mathematically irreconcilable with quantum mechanics, the rules that govern science's understanding of the universe on the subatomic scale. Relativity theory works on cosmic scales. Quantum mechanics works on subatomic scales. But for some reason, the two don't mix. So, testing general relativity is important because the ultimate theory of the universe must encompass both gravity and quantum mechanics. This latest test, reported in the journal Physical Review Letters, took a different approach. The new Event Horizon Telescope paper focuses on a previously unexplored parameter space for black hole research. It examined properties of the supermassive black hole at the centre of galaxy M87, which was imaged by the Event Horizon Telescope last year. This monster black hole is some 6.5 billion times more massive than the Sun. It's the first direct image ever taken of a supermassive black hole, or at least the shadow of a supermassive black hole. After all, black holes neither emit nor reflect light beyond their event horizons, the point of no return, beyond which matter and energy falls forever into the black hole singularity. Based on an analysis of the black hole shadow, the authors conducted a unique test of general relativity, deepening their understanding about the unusual properties of black holes and ruling out several hypotheses. The study's lead author, Professor Demetrios Saltis, says the first results showed that the size of the black hole shadow was consistent with the size predicted by general relativity. The intense gravity of a black hole curves space-time, acting as a magnifying glass and causing the black hole shadow to appear larger. The black hole shadow depends only on the geometry of the surrounding space-time and not on the astrophysics of the accretion process. And by measuring the visual distortion, the authors found that the size of the black hole shadow corroborates the predictions of general relativity. A test of gravity at the very edge of a supermassive black hole represents a first for physics and offers further proof that Einstein's theory remains intact, even under the most extreme conditions. The black hole shadow is unlike the shadows encountered in everyday life. Whereas a physical object casts a shadow by preventing light from passing through it, a black hole can create the effect of a shadow by siphoning light towards itself. While light can't escape from the interior of a black hole, it is possible, though unlikely, for light to escape from the region surrounding the event horizon, depending on its trajectory. The result is a murky no-man's land just beyond the point of no return, which appears to observers as a shadow. Gravitational tests of relativity looking at the effects of mass on space-time have been conducted in a number of cosmic settings. During the 1919 solar eclipse, the first evidence confirming general relativity was seen, based on the displacement of starlight travelling along the curvature of space-time caused by the Sun's gravity. More recently, tests have been conducted to probe gravity and general relativity outside the solar system and on cosmological scales. Examples include the detection of gravitational waves at laser interferometer gravitational wave observatories like LIGO and Virgo. Gravitational waves propagate through the fabric of space-time like ripples on a pond, just as predicted by general relativity. And these tests will become even more powerful once the Event Horizon's team image Sagittarius A star, the supermassive black hole at the centre of the Milky Way galaxy, a 4.3 million solar mass monster located 27,000 light-years away. And even more detailed observations will be possible when additional telescopes are added to the current Event Horizon telescope. In reality, an interferometer composed of numerous individual radio telescopes, all connected electronically through supercomputers to act as a single giant telescope the size of the Earth. In addition to providing a brand new test for all alternative formulations of gravity, it also connects the constraints from black hole images to those of other gravitational experiments. Such diverse perspectives are essential to a more comprehensive understanding of the underlying nature of black holes. The nearly circular shape of the black hole shadow, as observed, may also lead to a test of the general relativistic no-hair theorem, which states that a black hole is described entirely by just its mass, spin, and electrical charge. In other words, two black holes that possess the same mass, spin, and electrical charge would be considered indistinguishable from one another, similar to the identical nature of like subatomic particles. But should geometric irregularities be detected, it would potentially indicate the existence of additional black hole properties beyond mass, spin, and electrical charge. Meanwhile, in a separate study, a parametric model of the shapes of black hole shadows in non-Kerr spacetimes, published in the Astrophysical Journal, the team explore the size and shape of the black hole shadow by modelling several different spacetimes and theories of gravity. The authors say the black hole images are providing a completely new angle for testing Einstein's general theory of relativity. And together with gravitational wave observations, they mark the beginning of a new era of black hole astrophysics. This is SpaceTime. Still to come, restrictions imposed by the COVID-19 pandemic forced NASA to delay its Northern Territory rocket launch program. And later in the science report, an estimated 1 in 10 people worldwide now infected with COVID-19, and we look at the 2020 Nobel Prizes in physics, chemistry and medicine. All that and more coming up on SpaceTime. Equatorial Launch Australia says it'll be the middle of next year now before NASA begins launching rockets from its new East Arnhem Land facility. Restrictions imposed by the COVID-19 pandemic forced NASA to delay its Northern Territory launch program, which should have been underway by now. The site near Nhulunbuy, some 700 kilometres southeast of Darwin, will launch at least 4 Black Barat-sounding rockets carrying scientific payloads on suborbital ballistic missions. The payloads will include spectrometers to study light from the Alpha Centauri triple star system, looking for atmospheres around exoplanets, and to detect interstellar gas so as to better understand the structure and evolution of galaxies. Equatorial Launch Australia, which operates the site, has secured a contract with the American Space Agency for an initial 3 launches next year. Being just 12 degrees south of the equator, the launch complex is located in an equatorial sweet spot for launching payloads into space. In fact, only the European Space Agency's Kourou spaceport in French Guiana is better situated at just 5 degrees from the equator. You see, being on or near the equator provides launch vehicles with extra delta V or velocity when launching to the east. That comes about because of Earth's rotation, and it amounts to an additional 4.5 kilometres per second compared to launches at higher latitudes. Now, all that additional boost translates into extra payload for the same amount of fuel compared to launches from facilities such as Cape Canaveral, Vandenberg, Baikonur, or any of the launch complexes in Russia, India, China, or Japan. This is Space Time.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
And time now to take a brief look at some of the other stories making news in science this week with a science report. An estimated 1 in 10 people worldwide, that's 10% of all humans, have now been infected with the COVID-19 coronavirus. The new figures by the World Health Organization means the real level of infection now stands at close to 800 million people globally, compared to the over 37 million officially diagnosed. In the 11 months since the deadly virus first originated in Wuhan, China, more than 1 million people have died from the infection. But a report in the journal Nature says scientists warned that figure probably also vastly underestimates the actual number of people who have died from COVID-19. Worse still, epidemiologists with the University of Washington's Institute for Health Metrics and Evaluation in Seattle estimate that if current trends continue, more than 2.5 million people will have died from the coronavirus by the end of this year. But they say that figure could be cut to 1.8 million if every country adopts universal mask wearing. The 2020 Nobel Prize in Physics has been awarded to Roger Penrose, Reinhard Genzel and Andrea Ghez for their research into black holes. Penrose used ingenious mathematical methods. His proof that black holes are a direct consequence of Albert Einstein's 1915 general theory of relativity. Interestingly, Einstein himself didn't believe that black holes really exist. Meanwhile, Genzel and Ghez each led a group of astronomers that, since the early 1990s, have focused on a region known as Sagittarius A star at the centre of our own galaxy, the Milky Way. They studied the orbits of bright stars closest to the centre of the galaxy and concluded that these stars, based on their velocity and orbits, suggest they must be circling an object smaller than our solar system, but with as much mass as 4.3 million suns. They concluded that the only possible explanation is that Sagittarius A star is a supermassive black hole. The 2020 Nobel Prize in Chemistry has been awarded to Emmanuel Carpentier and Jennifer Doudna for their development of CRISPR-Cas9, the genetic scissors for genome editing. CRISPR-Cas9 has revolutionized gene editing, allowing scientists to change the DNA of animals, plants and microorganisms with extreme precision. This technology has had a major impact on all life sciences. It's contributing to new cancer therapies and may ultimately make the dream of curing inherited diseases come true. Meanwhile, Harvey Alter, Michael Houghton and Charles Rice have been awarded the 2020 Nobel Prize in Medicine for their discovery of the hepatitis C virus. Alter studied the transmission of hepatitis from blood transfusions. Previous studies had already identified the hepatitis A and B viruses. But Alter showed that a third blood-borne viral pathogen, hepatitis C, could also transmit the disease. Houghton identified the virus using infected genetic material, showing that it was a new kind of RNA virus belonging to the flavivirus family. Rice and colleagues then used genetic engineering to characterize a portion of the hepatitis C genome responsible for viral replication, demonstrating its role in liver disease. Okay, let's go from the sublime to the ridiculous. And a study linking 5G cell phone technology with the COVID-19 coronavirus has been slammed as unscientific and possibly the worst paper of 2020. It makes claims which can't be supported, using figures which are unprovable, and is based on claimed facts that simply aren't real and which have been described as badass crazy. Yet somehow this paper managed to get itself published in the journal Biological Regulators and Homeostatic Agents, which is published by BioLife. Now, the journal has retracted the paper, but they've not properly explained how it passed their so-called peer review process, or even if it was properly peer-reviewed at all. Tim Mendham from Australian Skeptics says the authors of the paper clearly have a problem with 5G and with maths, and when you think about it, they've got a problem with science as well.
The story goes that this was research done by various groups put together. Italy, US and Russia was where the researchers came from. What they supposedly found was that 5G waves could be absorbed by dermatologic cells acting like antennas, transferred to other cells and play the main role in producing coronaviruses in biological cells. So that raised a lot of red flags for a start. So you talk about producing coronavirus rather than catching coronavirus. But there are a whole range of different things that really made it look very strange. Because cancer is only one of the many problems, 5G causes 720 factorial different diseases in human beings and can kill everything that lives except some forms of microorganisms. And people looked at that and said 720 factorial is probably, I think it's actually more molecules than there are on the Earth. Probably aren't that many diseases. In fact, there's only about 13,000 diseases that are generally recognized. So they're claiming a hell of a lot more diseases than there are. So people thought, is their maths that bad? And so there's a whole range of different things about this paper that made it dodgy. The journal itself, they say they're peer-reviewed, but this one supposedly snuck through. One person's called it the worst paper of 2020. An organisation called Retraction Watch, which looks at scientific papers and see which ones are withdrawn. Most publications don't like to promote the fact that they've withdrawn a paper. They've looked at it and they asked the publishers, why did this happen? What was the process? How was this peer review? And the response was that there were too many papers, so they didn't have a chance to look at them all.
So
it wasn't. Well, I don't know if it wasn't. They said it wasn't really published yet because it was only online.
There was a pre-press version.
Yeah, pre-press version, but I think it's still supposedly have been peer-reviewed, and they just said some papers can just slip through the net, which is not a very good thing for peer-reviewed. The interesting thing is the response they got, this Retraction Watch got, didn't come from the editor or the publisher. It actually came from someone from the accounts department. And they thought, hang on.
Let's get our priorities right here.
Yeah, I know. And they said, right, okay, it's probably the first time they've ever got something from that particular part of an organisation.
What sort of reputation does BioLife have as a magazine?
I do not know, actually, and I probably wouldn't like to say in public, but it's been withdrawn, so a lot of people sort of made fun of it, and they said, oh dear, and they took it down and tried not to make much of a fuss about it, but of course other people did, so they paid the price.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.